Today's lesson is going to talk about relations and functions. A lot of this stuff should be familiar, should have seen this in the past, so this is kind of just a refresher. So to start off with what a relation is, basically a relation is just a collection of points or a collection of ordered pairs. So with that, there's actually 4 ways that you can show this so-called collection. So you can actually just write the ordered pairs if you want. So let's just do 3, 2, 0, 1, and 3, negative 6. So we'll just do those for an example. But that's one way to show that relation. So that whole group of ordered pairs is a relation. A different way that you can show these ordered pairs is to map them. So we're going to translate basically the ordered pairs into a map. So when you do a map, you need an X and a Y. And I always draw circles around my values. You don't have to, but that's usually what I do. And then you list all your X values in the X circle. And you're not allowed to repeat. So even though I see 3, 0, 3, I can only write 3 and 0. I can't repeat 3. And then my Y values will be 2, 1, and negative 6. And then you have to indicate which X connects to which Y. So 3 will connect to 2, 0 to 1, and 3 to negative 6. So you should see the number of ordered pairs should match the number of arrows that you have. The third way is a table, and we've been doing tables for a long time, so that shouldn't be anything new. And just a reminder, you do repeat in a table, you don't repeat in a map. Or you can show the ordered pairs by graphing them. So you could show 3, 2, go right 3 and up 2, 0, 1, or 3, negative 6. So basically in your homework, you're going to have to decide, maybe they'll give you a map and they'll say express these coordinates as a list of ordered pairs. So you have to list the ordered pairs from a map. They might give you ordered pairs and say express this relation as a table. So then you're going to have to construct a table and put your ordered pairs in that. So you just need to make sure that you can go from one thing to another. So sometimes relations are what we call functions, and a function is basically a one-way relationship between two amounts of something. So when I say one way, that means that every x value will have exactly one y value that matches up with it. Basically, in layman's terms, this means you can't have any repeating x's in order to be a function. So if I have, say, 2, 0, and I have 2, 1, right here, I like to call this a 2 timing x, and no one likes a 2 timing x, so it would not be a functional relationship. However, if you were to switch these, then it would be a function. You're allowed to have a 2 timing y, but you can't have a 2 timing x. So with word problems that are functions, you're always going to have a dependent and an independent variable, which we'll talk about in a minute. So for example, let's say we have a word problem and we're talking about the amount of allowance you get. So that's going to depend on something. Maybe it depends on number of chores. Maybe we'll talk about your grades in algebra. Well, that would depend on maybe the number of hours you study. An example of another scenario that we talk about a lot is salary. Usually depends on how much you work. So when we graph these functions, we are going to use a coordinate plane. Again, this isn't new, this is mainly review. So it's just important that we know where the 4 quadrants are, the x, the y-axis, and the origin. So those should already be known. And just as a reminder, the origin is always in the middle. And the coordinates of the middle will be 0, 0. You can already see your x-axis and your y-axis. And then your 4 quadrants will start in the upper right. That's 1. You move to the left, that's 2. Quadrant 3. And quadrant 4. So when you're given a coordinate plane that does not have your x or y axes drawn, you have to draw them yourself. So I usually pick the middle of the graph in both directions, and I shade those lines really dark. And then it's always a good habit to label. And we're just going to plot our 4 ordered pairs. So we have 4, 3, -2, -4, 0, -2, and -3, 0. So in your 2 circles, you're going to write x and y, because we need to get familiar with the vocab that's associated with them. Another word for x values would be input values. So then obviously y would be outputs. Sometimes we call x independent, and we call y dependent. We can also refer to x values as the domain, and y values would be your range. So all these words mean the same thing. They all mean x values. All these words mean y values. So in the graph above, zoom out a little bit here, it says to make a list of the domain. So your domain will consist of all your x values. So that would be 4, -2, 0, and -3. Now we go on to the y values for the range. So we'll have 3, -4, -2, and 0. And then you're supposed to answer whether or not the relation is a function. So you just do a quick check. There are no 2 timing x's, so I would say yes, because no x repeats. So what we have are 7 examples, and you have to determine if they are functions or not functions. So if you look at number 1, it's not, because 3 is a 2 timing x. So you can just write no because 3 repeats. If I look at number 2, all the x's have one relationship. You don't look at the y column, only the x's. So 2, 3, 4, and 5 are all being honest, so it is a function. It's the same thing with 3. These are all different numbers, so it is a function. Last year, you probably learned about the vertical line test for an example like 4. So you just draw a vertical line, and as long as it only touches the graph one time, it is a function. If it crosses twice, I usually say it's double crossing. It's not a function. So just a reminder, don't count your axes as part of your graph. Okay? They are imaginary lines. They're in the background. They don't count. You look at strictly the red graph. So it looks like it will always pass the vertical line test. Number 5 is definitely no, because 4 repeats. Number 6, try the vertical line test. Okay, that touched once. Let me draw another vertical line. Oh, touched twice, it fails. So that's a no. Number 7, Draw some vertical lines here. Touched each of those one time, so yes, we don't have any double crossing.